Good morning to all. I am Madhu Babu, lecturer in civil engineering, presently working at Government Polytechnic, Masabtank, Hyderabad. Today we'll be discussing about a topic called thin cylinders, which is a part of theory of structures. Presently, you can see this subject in C18 fifth semester curriculum. So, if you go into the subject, after completion of this particular tutorial, we can learn the or we can achieve the following objectives, which are: first one, we discuss about what is meant by a thin cylinder and what is meant by a thick cylinder, the basic differences between a thin cylinder and thick cylinders, and the most important part of this topic are Hooke stresses and longitudinal stresses, and how we can calculate in analyzing a particular cylinder. So, how we can define a thin cylinder? So, generally, a cylinder whose thickness is 20 times less than the diameter is known as thin cylinder. So, if you roughly consider a cross section like this, and thickness small t, and diameter, consider outer diameter small d, and according to the definition, if thickness is nothing but thickness of the cylinder is less than 20 times of small d, we name it as thin cylinder. On the contrary, it is termed as thick cylinder. That is, if small t is greater than or equals to 20 times of d, we call it as thick cylinder. So presently in our syllabus, we have only about thin cylinders, while thick cylinders consist of complex analysis. So at this stage, we are not bothered about thick cylinders and its analysis, which is a complex issue, which we may come across in our higher studies. And right now, we'll just analyze thin cylinders in this subject. So generally, in our daily life, we can see number of cylinders. Most commonly, cylinders are employed for transporting or storing fluids, that is nothing but liquids and gases. And while we consider the common examples, we can see our LPG cylinders, which we use for our cooking purposes in our daily life, in our kitchens, and boilers. These are generally used in power plants, thermal for heating of water, boilers. These are generally considered as thin cylinders only, as the thickness of the wall will be less than 20 times of D. And other is Storage tanks. Storage can be any oil or water or anything else, etc. So these are the common examples which we see in our daily life as thin cylinders. So what are these particular cylinders which they are exhibited to because of storage of such fluids? Due to the fluids inside a cylinder, these are subjected to fluid pressure or internal pressure. We can say it as capital P. So diagrammatically, if we consider a cylinder like this, and these are the walls of cylinder. So as we have mentioned, subjected to these cylinders are subjected to fluid pressure or internal pressure, capital P, like this, and this will be common in all directions, which we'll discuss in our assumptions later. Hence, at any point on the wall of the cylinder, three types of stresses are developed in three perpendicular directions. So, as it is a three-dimensional figure, we have three perpendicular directions, and these three perpendicular directions, there will be a stresses induced because of this storage of fluids, and and further we'll discuss what are those stresses and how we can calculate those stresses and how those stresses will affect the dimensions of the cylinder. So if we go into the types of stresses, we have, as I have mentioned already, we have three types of stresses. First one is circumferential or hoop stress. Generally it is denoted as sigma suffix h. And second one is longitudinal stress, denoted as sigma suffix small l or capital L. And the third one is radial stress, sigma suffix r. So in any analysis, we have certain assumptions for our own convenience or in the analyzing. In the same way, we have assumptions in this topic also. What are those? It is assumed that the stresses are uniformly distributed throughout the thickness of the wall. So important part is it is assumed that the stresses are uniformly distributed throughout the thickness of the wall, as we can see in this particular image. In all directions we have capital P. So as the magnitude of radial stresses, and the next one is magnitude of radial stresses is very small in thin cylinders. They are neglected while analyzing the thin cylinders. Nothing but sigma r value will be 0. This is the important assumption in our analysis. So we are considered or we are bothered about only two stresses which are sigma h and sigma L. So these things we need to find out in our analysis. So how we can find sigma h and sigma L, we'll discuss now. So as there are three stresses, first one is circumferential stress or hoop stress. So we can define this stress as it is directed along to act tangential to the longitudinal axis of the cylinder. So diagrammatically we can show like this. If we consider a cross section like this of a cylinder, we can see this arrows which is denoting the internal pressure which is acting throughout the circumference of the cylinder. So in definition they have mentioned that it will act the tangential to the longitudinal direction. And what are the common features of this stress? First one is this stress is tensile in nature. So it will try to enlarge this cylinder like this. And next is it will tend to divide shell nothing but cylinder into two equal halves. So in diagram you can see here as the whole cross section is divided like this, like this. See the first part and this is the second part. This got divided from this. So as they are symmetrical, this particular hoop stress can divide a shell into two equal halves. This stress tends to increase the diameter. That's what I mentioned earlier. As it is tensile in nature, it will try to enlarge the diameter. So particular the circular section may become like something like this in oval shape or ellipse. The diameter will get enlarged to E dash. And because of this particular stress, the failure can be in longitudinal direction, as we can see like this. In longitudinal direction, the failure we can observe because of this stress. So how we can calculate this hoop stress is there is a small derivation to create an equation for calculation purpose. So generally there will be two types of forces under equilibrium, which will be one is resisting force and other is which will create an effect to the member. Here total diametrical bursting force, so this will create the damage to the section. So that is because of internal pressure capital P. So how we can calculate this bursting force is equals to capital P into projected area of the curved surface. What is nothing but what is this? Projected area. Nothing but projected area of the curved surface. This one. The projected area will be this thing, small d. So this is projected area into length of the cylinder which we have considered. So what will be the bursting force here? Capital P into D into capital L. So this will be the bursting force. To nullify this bursting force, we have resistant force due to circumferential stress, that we can write it as 2 into sigma h into T is small t is, as I have mentioned, thickness of cylinder into capital L. So as we have two equations here, under equilibrium resisting force will be equals to diametrical bursting force. If we equate them, we'll get an equation like this. Sorry. We'll get an equation like this. 2 into sigma h into small t into capital L is equals to capital P into small d into capital L. So after cancellation of capital L, we'll get an equation like this. Sigma h equals to capital D into P by 2 times of T. So this is our equation for calculation of circumferential stress. Sigma h equals to capital B P into small d by 2 times of T. So this is the first major equation for analyzing a thin cylinder in your syllabus. So next comes the another stress, which is known as longitudinal stress. So this stress is generally defined as a stress which is directed along the length of the cylinder. So in this diagram, you can see a capital P, which is internal fluid pressure. On the other, on this side, on the other side, you can see the sigma L, sigma suffix L, stress along the length of the member, like this one. So even this stress has nature of tensile characteristics as compared to Hooke stress. As because of this tensile nature, this stress tends to increase the length of the member. So this will try to pull the cylinder such a way that it may increase its length. So earlier in Hooke stress, we can see it has a nature of increasing its diameter. Here the length may get increased. So combined effect will be because of hoop stress, diameter may get increased, and because of longitudinal stress, length of the cylinder may get increased. So overall, if we consider this nature, this effect, the cylinder may get busted if there is an excessive internal fluid pressure. So how we can calculate this longitudinal stress effect? The same manner which we have derived an equation for hoop stress, we can derive an equation for this particular longitudinal stress also. Here, the longitudinal bursting force which is acting on both ends of the cylinder, this is that can be written as P into pi by 4 into this is d square. So this can be written as P into pi by 4 into d square. This is the first equation. And where is this longitudinal stress is developed? Along the this cross section. This cross section. So that can be written as pi into t into t. So resisting force will be due to longitudinal stress. That can be written as sigma L into pi into small d to small t. This will be our second equation. So under equilibrium, resisting force will be equals to total bursting force. Nothing but equation 1 equals to equation 2. So here it should be t square. This is pi. So if we equate equation 1 and equation 2, sigma L into pi into d into t equals to capital P into pi by 4 into d square. So here we can cancel pi and pi here and d and 1 d here. So ultimately we'll get sigma L equals to P into d by 4 times of t. This is our equation for calculation of longitudinal stress. Uh, that is capital P into d by 4 times of small t. This is nothing but thickness of cylinder. So here we may observe that sigma h is equals to PD by 2t and sigma L is equals to PD by 4t. So if we compare these two equations, or if we take a ratio of these two stresses, sigma h by sigma L, that will be equals to 2. Implies sigma h will have Why is the effect of sigma L? Nothing but hoop stress will be having the double the effect of longitudinal stress. So circumferential stress is most important thing than compared to longitudinal stress. That doesn't mean we can neglect the longitudinal stress, but the effect, if we see, hoop stress or circumferential stress has more compared to the longitudinal stress. So with this we can conclude this tutorial. As I have mentioned earlier, in this tutorial we can achieve the following objectives. We have learnt about what is meant by thin cylinder, and we have seen what is meant by a thick cylinder. If we quickly review, a thin cylinder is considered as which is having a thickness of less than 20 times of this of its own diameter, and opposite to that, a cylinder which has thickness greater than or equals to 20 times of d, it is known as a thick cylinder. So what is the basic difference? We have seen that basic difference will be the thickness itself, and the analysis part which I have mentioned, thin cylinders will have easy kind of analysis, while thick cylinders will have complex equations and complex things to be analyzed. And next is, we have seen what are different types of stresses, in that particularly hoop stress or circumferential stress, which is generally denoted by sigma suffix small h, which has a equation which we have derived just now, which is capital P into D by 2 times T. And the next is longitudinal stress, which has a value of capital P into D by 4 times of T. Also, we have seen certain relation between sigma h and sigma L. So that is sigma h is equals to 2 times of sigma L. This way. So, so these are the things which we have achieved in this tutorial, and we'll conclude it here. In the next class, we'll further discuss in detail about these stresses and what are the strains which we can analyze, which are actually developed because of these stresses, and further we can discuss about the, or we can solve some numericals on this particular topic. Thank you.